Installing wire communications, especially in forward areas, is a difficult and dangerous job. It always takes time, often takes lives. Ordinarily, this will give us 2 channels. But suppose we need 3 or even 4 channels. If we can obtain them without laying extra wire, we may save lives and we'll certainly save time. A line can carry more than one message. The problem is to separate the messages at both ends of the line. The easiest solution is to use simplex and phantom circuits. The basic device used in establishing these circuits is the repeating coil. This is nothing more than a small transformer. It consists essentially of an iron core and 2 windings. Here's what happens when we send direct current through one of the windings. A magnetic flux builds up in the core. Now, let's see what happens when the other winding is part of a closed circuit. Current flows through it during the instant while the magnetic flux is building up. As soon as the magnetic flux reaches a steady value, however, this induced current disappears. Watch what happens when the current supply is cut off. As the magnetic flux dies, current again flows for an instant in the second winding, this time in the opposite direction. This, then, is the first important fact about a repeating coil. It blocks direct current except at the instant when the current is changing. Now let's consider alternating current. We'll first give you an idea of how it works by sending direct current through the coil. First in one direction, then in the other. Notice that the induced current in the second winding reverses each time the supply current is reversed. Now let's speed it up. The 2 currents begin to resemble each other. By replacing the battery with an AC generator, we get a true alternating current, which is reproduced almost exactly in the second winding. Here's the second important fact about a repeating coil. It repeats alternating current practically unchanged. So far, so good. But suppose we want current to flow in one winding without producing any effect whatever in the other winding. We can do this by connecting the exact midpoint of one winding to one side of our current source and connecting the other side through equal resistances to both ends of the winding. Now let's close the circuit and watch the path of the current. Because the resistances are equal, the current divides equally between the 2 halves of the winding. There are now 2 equal currents flowing through the winding in opposite directions. Their magnetizing effects cancel each other, so no flux is produced in the core. Consequently, no current is induced in the second winding, even when the current in the first winding is changing. Therefore, the same principle applies to alternating current. This is the third and most important operating principle of the repeating coil. When either alternating or direct current is introduced at the midpoint of one winding and is made to divide equally between the 2 halves, no effect is produced in the other winding. This principle is most important, for it permits 2 channels of communication over a single circuit. Here is a simplified model of a local battery switchboard. Let's suppose we have a line to a second board several miles away. These resistors represent the normal line resistance. We want a telegraph channel between these 2 points. Here's where our repeating coils come in. We have seen that the coils repeat alternating or telephone current, so our telephone line is unaffected. Now we can connect the telegraph set to the midpoint of the line side winding of each repeating coil and complete the circuit through the earth. We have added the telegraph channel by using only a few extra feet of wire. The switchboards can still signal each other. The newly installed telegraph circuit can operate without interfering with the original telephone circuit. This new channel is a simplex circuit that may be used for either telephone or telegraph. It is rarely used for telephone, however, because like all ground return circuits, it is apt to be noisy. Here's how the whole thing works. When one telegraph operator sends a message, the other receives it. The current goes from the telegraph set to the midpoint of the repeating coil's line side winding. Since both line wires are of equal resistance, the current divides equally in the repeating coil. The currents continue through the line wires until they meet at the midpoint terminal of the other repeating coil. Here, the current becomes 1 again and flows into the east telegraph set. The circuit is completed through the earth. The telegraph current doesn't interfere with the telephone circuit. Here is why. Since the equal parts of the telegraph current flow in opposite directions, no current is induced on the switchboard side. The same thing is true of the east coil and switchboard. Now for the telephone circuit. Here is the path for ringing current from west to east. Voice currents would follow the same path. What prevents the telegraph sets from receiving telephone current? Let's freeze that current again. The upper half of the winding is trying to send current through this path. And the lower half of the winding is trying to send current through this path. Since the resistances of the 2 line wires are equal, 2 equal currents are trying to flow in opposite directions through the telegraph sets. They buck each other and no current flows. Consequently, the telephone circuit doesn't interfere with the telegraph. In reality, the telephone and telegraph currents combine in each wire to form a single current.
Johnny, get your gun, get your gun, get your gun. Take it on the run, on the run, on the run. Hear them calling you and me, every son of liberty.